Presenting Amber. Presenting Lily. Presenting Isaac Newton.
Today we're learning about the universal law of gravitation.
Isaac Newton created the universal law of gravitation in 1687. He did this by combining Kepler's law of planetary motion and Galileo's theory of falling bodies.
In other words, he compared the acceleration of the moon in its orbit with the acceleration of falling objects on Earth's surface. This created the universal law of gravitation. You might be wondering, what gave him the idea to create this law? Well, let's show you.
One sunny day.
Later on, Henry Cavendish would go on to test this law. Einstein would propose that gravity was a result of warping space-time. This theory was called general relativity. Say the thing.
Eureka!
Now, force is equal to the gravitational constant multiplied by the product of the masses divided by the square of the distance. Let's take a second to go over the variables. So first we have F, which is force, then G, which is the gravitational constant. Then M1 and M2 are basically the same thing, but this is the mass for object 1, and this is the mass for object number 2. And then this is the distance between the centers of the two objects. Now we're going to do our units for each of these. So we have newtons times meters squared divided by kilograms squared. Then for mass, it's in kilograms. And distance is meters. Now we take our usual equation and plug in the units instead. We can figure out how exactly we get these units for our gravitational constant. So in order to do that, we must rearrange it. Now, first things first, in order to cancel out these meters so we can get straight to D, we're going to need to multiply by meters. And then that would give us force times meters squared, of course. But let's just write that as Newton times meters squared. And then we still have equals G times kilograms. And these 2 kilograms are technically just grams squared. Okay, so we can erase that. But G is being multiplied by kilograms squared, so that means we need to divide this by kilograms squared. And that is where our units for the gravitational constant come from. Newtons times meters squared divided by kilograms squared.
Let's do a problem.
Let's say a 40-kilogram fish is located at a distance of 43 meters from the center of a large boat with a mass of 1,500 kilograms. What is the force?
Okay, so first in this equation, let's go ahead and label our units of our equation. So our G stays the same. It is a constant. So it's going to be 6.67 times 10 to the negative 11. Then our M1, the fish, is going to be 40 kg. Then our boat, M2, is going to be 1,500 kg. Our D/R is going to be 43 meters. And what we're trying to find here is our force. Also, crowds, I almost forgot my units on my gravitational constant. It's newtons times meters squared divided by kilograms squared. Don't forget! Now, we have our equation. F equals G times M1 times M2 over R squared, or D squared. Same thing, both mean distance. Now, if we plug what we've got in, this is what we'll have. F equals G, which is 6.67 times 10 to the negative 11th, and that's in M squared over kg squared times 40 times 1,500. And both of these are kilograms over 43 meters squared. Okay, now if I pull out my trusty TI-84 and enter all these numbers in exactly like so, and then press enter, we get our answer. 2.16, that's it, times 10 to the negative 9th. Woohoo! Now, you may be wondering, what are the units for this force? Well, of course you've been thinking, oh, it's newtons, it's force. Newtons like me. But I'll show you exactly how we get those units. Now here's our problem once again, but this time we're going to ignore the numbers and focus on the units. Okay, so we have meter squared here, and we have meter squared here. So those cancel out. Then we have 2 kilograms times kilograms, which is also kilograms squared, and there's a kilogram squared in the denominator. So that also means they'll cancel out because they're reciprocal of each other. So then we're just left with newtons. So that means our final answer is in newtons. 2.16 times 10 to the negative 9th newtons is our final answer.